Right, here we go, the first in the C3 and C4 series on revising for the exam. And we are just about to go on and have a look at these trigonometric questions. They're quite useful for someone who's listening could just check they can hear me in chat. Or say they can, because I can't see a video appearing in the live stream, even though it says I'm live. Be grateful if you could just, someone could identify that they are watching. Can those watching just say if they can see the actual stream formally in fact, the actual screenshot, please? Okay, well, I can't see the stream at the moment appearing on the screen, and nobody's telling me they can see it or hear it, which means I'm just going to try and stop the stream and right, I can't see if the stream is working now. Yes, you can see the video. Okay, right, I've got a positive comment on that. Okay, I'll carry on now. Right, the things you need to see is these, you need to know, for C3 trigonometry, you need to know all these things. I'm going to assume you know that you need to know all those things, but I've just put them in the formulae and facts that you need to know before being able to do any trigonometric questions. I'll now move on to our first question we're going to look at, which is this one with cosec and sec. And I'm going to give you 7 minutes to have a go at this before going through it. So here you go. Set the timer for 7 minutes. Have a go at this one, and then I'll run through this question. Sorry about that. I just realised I've been talking and no sound. I apologise for that. I'll just talk you through the example again. Sorry, I turned off my mic. I've got sound now. Thanks for letting me know. Let's just quickly run through this. I'll highlight different sections. So what I spotted first was that I've got cot 3 theta is equal to cot squared 3 theta minus 1. And then multiply out the brackets to get that. And I did have previously a minus 2 there. So, and then when I added the 5 across, obviously simplified that with plus 3. I let c equal cosec 3 theta, so as to just be lazy about writing out the factorization. And once I've got that, then I know that equals 0 or that equals 0. And therefore, we get cosec equals a half, which means that sine is equal to 2, which there are no solutions. And then we solved all the solutions. 3 theta equals a third. Our range is from 0 to 180, but 3 theta will be between 0 and 540. So you can see we got 180 there, another 180 and another 180 to give us 3 thetas, and hence why I looked up 4 possible values. If you're uncertain, 180 minus x. Did I make a mistake with 180 minus x? Ooh, I did. Well spotted, Robin. Okay, I'm sorry, I made a mistake here when I did 180 minus x. I must have typed in 80 minus x by accident. So that means these two values will be wrong. Okay, so that'll be about 160.52. And then obviously this one here is going to be another 360 onto that. So that's going to be 360 onto that. That's going to be 420.52. And so therefore divide them by 3 to get these two answers. Well spotted. Okay, so those therefore will be very different answers. All right, and yes, you'll get about 53.51 from that one there. All right, I've just got that chat through. You'll have to bear with me. It is lagging a little bit. Thanks for the feedback. Let's go on to the next question now. Right, I'm going to give you, this one is a much trick. This is an international A-level question. Giving it there for those of you who are a little bit more advanced and think you're very secure. There's quite a tricky finish to this. You may spot it. Okay, let's see how you get on with 7 minutes on this. Right, let's in time up on that one. Need to be aware that you are lagging me by about 20 seconds, so it will take me a little while to respond to any questions. What we'll do is when I finish this question and finish off talking about the C3, before we go to start the C4 section, I will stop the stream, then restart the stream. So anyway, I'm just going to zoom this out so I've got more space to work, because you've been looking at the question, you should know the question by now. Now, given that this, without using a calculator, prove this. So let's start off with this. And what we've got to do is expand this. So we're going to get 2 cos x cos 30 minus 2 sin x sin 30. And I'm going to run out of space. So I'll just press the equals on the next line. Sin x cos 30 minus cos x sin 30. And you need to know your sine, cos and tan of 30, 45 and 60. You should know those all by now. You're doing C3, not C2 anymore. So if you don't know them, make sure you go away and learn them. So cos of 30 is equal to root 3 over 2. Sine of 30 is equal to a half. Cos of 30 again, we're going to use the same thing, so times by root 3 over 2. And we've got sine of x again is going to be times by a half. So therefore we can get all the causes on the same side. So if we get all the causes on the same side, we get 2 let me simplify this. That's going to be root 3 times cos x. And I'm going to get minus a half, or actually plus when I get to the other side, a half cos x. And then on the other side, I'm going to get sine a root 3 over 2 sine x. And I'm going to take this to the other side. That will just be plus sine x. And let's factorize these out. So I'm going to get root 3 plus a half. I'm going to actually turn that into a single fraction. So that will actually, if I times top and bottom by this by 2, I get 2 root 3 plus a half, 1 over 2 for cos x. And combine these, and I get root 3 over 2 plus 1 sine x. Convert that into a single fraction. Let's just do that while we're here. So I'm going to get plus 2 over 2 sine x. Divide by to get tan. And then I'm going to divide by this, which means I'm going to reciprocate and times by it. So I'm going to get 2 root 3 plus 1 over 2 times by the reciprocal of 2 root 3 plus 2 equals tan x. Sine divided by cos is tan. 2's cancel. And so I get 2 root 3 plus 1 over root 3 plus 2. So I'm going to times top and bottom by root 3 minus 2 to get rid of the surds on the bottom. So times both top and bottom by root 3 minus 2. And I'm just looking at this, and somehow I made a mistake in my answers and fluked correct one previously when I was just checking it before. Anyway, let's get on with this. Root 3 minus times root 3 plus 2 will give me 3 minus 4 on the bottom. On the top, root 3 times 2 root 3 is going to give me 2 times 3, which is 6. Root 3 times 1 is going to give me another root 3. Minus 2 times 2 root 3 is minus 4 root 3. And I've got another minus 2 times 1, which is minus 2. So I'm going to get 4 minus 3 root 3 over minus 1 equals tan x. And if I times top and bottom by minus 1, I get 3 root 3 minus 4 equals tan x, which means I've now shown it. Now, the second part of the question. Right, I'm just going to start the stream again. This is look at the C4 section of the stream, just checking that the stream seems to be caught up. I'm not sure whether actually that last bit managed to get all the way through on the recording to you guys. Hopefully it did, because I saw it was doing a bit of lagging for me. Anyway, this is the partial fractions section. And we're going to look at the two types of partial fractions you need to be able to do are these two. You also need to know how to deal when the numerator has a greater degree than the denominator, and that basically is you divide out the fraction first. Okay, and then you need to be able to do standard partial fractions and ones where you have a repeated factor. And know that this is the way you deal with both. Anyway, we'll just quickly test you on that. So we'll give you 3 minutes to have a go at this one. And then we'll do another standard one, 3 minutes, and then we'll show, oops, sorry about that. We'll have an application of a partial fraction in a real problem after that. These are all past exam questions. These two, obviously the easier ones, but question 3 will be a little bit more interesting. Right, when you've got the numerator greater than, at least the equal power or greater than the denominator, then you need to divide out first. Okay, we can see the bottom is a quadratic, the top's a quadratic, so I'm going to just multiply out the bottom to get 3x squared plus 6x minus x, that's plus 5x minus 2, and I'm just going to divide that into my 9x squared plus 20x minus 10. So 3x squared into 9x squared goes 3 times. So times is backed by 3. I get 9x squared plus 15x minus 6. And I want to subtract that all to see what I got left. And what I have left is 5x minus 6 from 10. Minus 6 from 10 gives me minus 4. So therefore 9x squared plus 20x minus 10 over x plus 2 at 3x minus 1 must equal 3 plus 5x minus 4 over x plus 2, 3x minus 1. And I've got to turn this right-hand bit into partial fractions. So I'm just going to move that up there to give myself more space. So 5x minus 4 over x plus 2 times 3x minus 1. will equal a over x plus 2 plus b over 3x minus 1. And therefore, I'm going to 5x minus 4 must equal a times the 3x minus 1 plus b times the x plus 2. And if we let x equal minus 2, on the left hand side we get minus 14 will equal, it's going to be minus 6 minus 7a, and the b bit goes to 0, so that implies that a equals 2. And if we let x equal, what's that going to be, a third, to get the a bit to be 0, then we're going to get 5 over 3 minus 4 will equal b times by, what's that, 1/3 plus 2, so that's going to be 7/3 on this side. 5 minus, so 4 is 12/3, so we're going to get minus 7/3 on this side when I simplify that. So that implies that b will equal minus 1. So we put that all into partial fractions. What we get is 3 plus 2 over x plus 2 minus 1 over 3x minus 1 for our final answer. Now I'm just going to briefly stop the stream there because again you're lagging it behind me again. I'm just going to count for 10 seconds and start the stream again so as we start level. Right, back with the stream again. So I'm just going to give you another 3 minutes to have a go at this question. Okay, this one should, actually I'm going to give you less than that because this one's a bit more straightforward if you know what you're doing. So 2 minutes should be plenty to do this question. Have a go at this one before we go have a go at the more interesting exam question. Okay, let's have a look at this. So we're going to let 5x plus 3 over 2x plus 1 brackets x plus 1 squared. What we need to do is we need to make that equal to a over 2x plus 1 plus b over x plus 1 plus c over x plus 1 squared. Now, I'm not going to go into reasons why we do this for repeated factors, but it's what we always do for repeated factors. Okay, it's not the scope of this video, it's just revision. So, therefore, if you want to know more, you need to go and look that up and make sure you understand why, or alternatively, just accept it. So, therefore, 5x plus 3 will equal a times x plus 1 squared. We need to times the denominator of this by x plus 1 squared to get the same denominator as that. Now b just needs to times by 2x plus 1 times x plus 1. Now a common mistake is to times it by the x plus 1 squared here. Some students do that. And similarly with c, you only need to times it by 2x plus 1 over here. Because we already have the x plus 1 squared, we don't need to times by any more to get the denominators the same. So if we let x equal minus 1, then we're going to get on the left hand side minus 5 plus 3 is minus 2. And then on the right hand side, the a is going to go, the b is going to go, because this bit will be 0 and this will be 0. So therefore we're going to get 2x plus 1, put minus 1 in there, you're going to get minus 2 plus 1 is minus 1, so you get minus c, so 2 will be equal to c. And if we let x equal a half, no, minus a half even, then this bit here will equal to 0 and this bit will equal to 0, so that just leaves us the a bit. So we're going to get minus 5 over 2 plus 6 over 2 is 1 over 2 on this side. Minus a half plus 1 is a half, squared is a quarter, so we get a quarter a, so therefore a equals 2. Now because we know a equals 2 and b equals 2, we can now let x equal something simple like 0 to finish off. So we let x equal 0, we get 3 equals a plus b plus c. And because we know a and c are both 2, so that gives us 4. And b, therefore, will be equal to minus 1. And again, we're already lagging on that question, so I'm going to have another quick pause before we go to the next question in the stream. I'll stop it briefly just for about 10-20 seconds to allow the stream to catch up. Right, back here again. We've got question 3 now. And this is where we start to earn our money. We have to apply the partial fractions to a proper question. So this one's binomial theorem, so I hope your binomial theorem is up to it. It's a 10-mark question. I'm going to give you 7 minutes to have a battle with it and see how you get on, and then we'll go through it. here we go. Last bit of the lesson. Let's just go through this question. I'm going to zoom that into one corner to have more working space. Okay, and I think I'm going to look at this. I'm going to write it down here. So let's get myself a pen. So I've got 2x plus 1 over 1 plus x times by 1 minus x squared. And I'm going to let that equal to a over 1 plus x plus b over 1 minus x plus c over 1 minus x all squared. So therefore that means that 2x plus 1 will equal a times 1 minus x squared plus b times 1 plus x times 1 minus x, to get the same denominator over here from there, plus c, they only need to times by 1 plus x. So if we let x equal 1, we get 3 on the left hand side. That's going to be 0, that's going to be 0, so that's just going to give me 2c. So therefore c will equal 3 over 2. And if I let x equal minus 1, then I'm going to get minus 1 on the left equals 2. That's going to be 0, and that's going to be 0. So it's minus 1. So I get 1 minus minus 1, which is 2, which is squared is 4a. So therefore a minus a quarter. And if I now I'm going to let x equal 0. I know a and c, so I can find b easily. So x equals 0, I get 1 equals a from here. Make it 0 there, I get just plus b. Make it 0 here, I get plus c. And when you've done all of that, I get minus a quarter here, and for a, 1 equals minus a quarter plus b plus 3 over 2. So that means that b will equal, take 3 over 2 is minus a half, add a quarter gives us minus a quarter here for b. Right, so now what we're going to do is we're going to find the expansion of this up into terms including x squared. And this is why I put it into partial fractions, because it becomes easy. Because if I now expand the first one, which is this bit here, which is going to be minus a quarter, 1 plus x to the minus 1, work that out. And then I'm going to do the next bit, which b is minus a quarter as well, times 1 minus x to the minus 1. And I can use that, a lot of similarities to help me. And c is 3 over 2, 1 minus x all squared. So I'm going to expand each of these in turn. Now I'm going to use the formula, and the formula for expanding is going to be 1 plus x to the n is equal to 1 plus nx, plus n open brackets n minus 1 over 2 factorial x squared. And I don't need to go any further because it only said up to x squared. So I'm going to expand up to x squared. So I'm going to get minus a quarter times by 1 plus x, and I'm going to get, no, not plus x because n is minus 1. Sorry about that. It's minus x. And I get minus 1, minus 2, so that's going to give me plus 2, divided by 2 is just 1, so that's just going to give me plus x squared. And you would have more to come. But we don't need it, so we get minus a quarter. Now, because we've just got a minus x everywhere, there's an x in here, so that will end up being a plus x. And minus x squared is still plus x squared. That makes no difference to that. That gives you those terms. And now we've just got to be careful. Oops, that's a minus there. So we've just got n is minus 2 in this. So we're going to get 1 minus 2x. But I've got a minus x in here, so I've got to be careful there. So it's going to get minus 2 times minus x. So it's going to give me plus 2x. And then what have I got? I've got minus 2, so I've got minus 2 times by minus 3, cancelled by 2. That's going to give me just 3 on the top. I've got a minus x squared, so that's just x squared. Let me just check that. Yep, that's looking good to me. Just want to write that out again because it's not the same as what I got before. So I just want to make sure I've done that correctly. I had -2 times by -3 over 2 times by -x all squared. That bits, so that cancels out with that to leave me just minus times minus gives me a plus. Yes, that looks good. So all I've got to do now is add up all these terms. So I've got -1/4, which is a -1/2, plus 3/2, which just leaves me just 1. And then these two are going to cancel out, so I don't need to worry about those. So I'm just going to get plus 3x. Then I'm going to get another -1/4 x squared, so that's -1/2 squared. So I've got -1/2 squared. I've got 3/2 times 3, so that's going to give me plus 9/2 x squared. So my final answer is 1 plus 3/x plus half away from that's going to give me 8/2, which is just 4x squared. And we've now expanded that as far as the term in x squared. And I can see this stream's lagging a little bit. So what I'll do is I'll leave it open just in case either I've made a mistake in here or you can't spot how to do it and want to ask a question. I'll leave the channel open to see your chat for the next few minutes.